Starting. Awesome. So as always with our Zoom classes and notes, I'm recording our class and I'll post the video of it once it gets all processed and uploaded right in our Zoom class videos section right here is the 23rd. And so it'll go right under the 23rd section right in here. So if you ever want to come back and see me go through the notes again, rewatch a video of us talking about it, it'll be right here. The actual notes for today, just like everything else, is posted a little bit further down below. So like I mentioned, the midterm went live this morning. And so hopefully you guys have at least taken a quick look at it so far. Again, it is not due until Friday. So you have plenty of time to work on it all day today, tomorrow, and Friday. And it covers everything from the last couple weeks of class. So the solids and liquids, the changes and characteristics, properties, the neutrons and protons and electron shells, all of that stuff will be on the midterm, as will some of the stuff that we're talking about today. So make sure you keep that in mind and get that turned in by the end of the week this week. All right. So today we're going to be talking about how matter is composed or classified, meaning that Monday we were talking about how those atoms stick to each other, whether or not they make the ionic bonds where they move the electrons around, or the covalent bonds where they share electrons between each other. Today we're going to look at a little bit broader picture and talk about how can we classify different types of matter. So how can we kind of separate different combinations of substances into different groups? And so we're going to start off by looking at a kind of big overview flowchart of all the different stuff we're going to talk about today, and then go through each one of those points one by one. So we start off with our matter, right, which is our stuff, our substance, our water, or maybe it could be like sand on the beach or a wooden block in front of you. Whatever type of matter it is, the first thing that is going to determine what type of substance we're dealing with is, can it be separated by physical means? And what we mean by physical is that you can use a strainer, or you can use like a filter paper, like a coffee filter, or you can use go in and pick it out on your own. So physical means just indicates that we have some way of easily separating the particles. And so maybe we have particles of all different sizes, and so we can use that filter paper to separate some out from the other. Maybe we have like a big, so a good example would be like if you have a big bag of like marbles, say, and you want to separate out the blue ones from the green ones from the red ones, you can easily physically separate them based on color. So if we can separate these apart pretty easily, we have what's called a mixture. So we have a whole bunch of different substances that aren't necessarily bonded to each other, right? Maybe they don't all have covalent or ionic bonds going on, but we have lots of different things that are all mixed together, hence the name. If it can't be separated by physical means, if all the different stuff in our matter is bonded together, that means we have a pure substance. So a pure substance is when we only have one type of molecule, one type of matter. So all of the atoms in a pure substance, they might not be all the same, but they're all bonded to each other. And we'll see some examples of what this looks like in a second. So if we go back to our mixtures, we have two different types of mixtures that we're going to focus on. One where all of the little particles are all completely and totally evenly spread out throughout the mixture, and that's called a homogeneous mixture, and we'll get to that in a little bit. If it's not all evenly spread out, if we have big chunks and pieces distributed in our matter, then it's called a heterogeneous mixture. Over on the pure substance side, if we have a substance where we have some different atoms that are bonded together, but if we put them through a chemical reaction, we could spread them apart. We have something called a compound. Whereas if we just have one single type of atom, only one type of atom is present, then that's just called an element. So like the periodic table that we've been talking about the last week or so, that shows all of the different elements that exist in the world. So if you have something like aluminum foil, for example, aluminum foil is made purely out of the element aluminum. There's only aluminum atoms in there. No other type of metal atoms are mixed in. So that would be an example of just a single element being present. And like I said, it might be a little bit confusing so far, but we're going to go through each one of these situations kind of separately and talk about each one. So first up, because they are the simplest, we're going to talk about our pure substances. So a pure substance is when there's only one single type of particle present in that substance. So we don't have lots of different things all combined around in different ways. There's only one type of particle. And we can split our particles into kind of two different categories, like we were just talking about. We have elements, where it literally is just single atoms. So you can imagine that these little dots are like atoms. So elements where we just have the single atoms spread around in an area. The other one is compounds. And a compound is when we have two or more different atoms. So like in this case, we have the little black dot atom and the white circle atom that are bonded together. So these guys are bonded together. They're different atoms that have been bonded into a compound. So this is still a pure substance because this particular compound, the one black and two white compound, is the only type of particle present, right? No other, there's no single black dots in here. There's no single white dots. The only thing present is this one black, two white compound. So that's what we mean when we say pure substance, where there's only one type of particle present. Sometimes those particles might be single elements. Sometimes those particles might be compounds, so multiple elements fused together. But as long as there's only the one type present, we have a pure substance. So next, we're going to break down elements and compounds a little bit further. So like I was saying, elements are when we have identical atoms. Every single atom in this picture is the exact same. There's only, in this case, black dot atoms, let's say. So metals are really good for making these large amounts of pure substances. So like I mentioned, aluminum foil earlier. You could also have a copper pot. So copper is an element. And so if you have a pure copper pot, that means that there's only copper in that pot. No other elements exist in that pot, in that vase. Same thing with these gold bricks over here. So gold is one of those kind of weird atoms. Its chemical symbol is Au. But so in these guys, there's only gold atoms in these bricks right here, in these gold bars. So they're completely made out of gold. Gold is the only atom that's present, and that's what makes it a pure element, a pure substance that is an element. Only one single type of atom is present. Compounds, on the other hand, a little bit more complicated than our elements. So compounds are when we have two or more elements bonded together. So those chemical bonds that we were talking about on Monday, those were making compounds. So two or more elements. And actually, I'm going to go in and change one thing here. It's not just two or more elements, it's two or more different elements. All right, so like in that last slide that we had a couple slides ago, we had the black dot and the white dots bonded together. So when you end up with these compounds, you might get properties that are different from the individual elements that make them up. So one compound that we talked a whole lot about on Monday is table salt, sodium chloride. Again, this guy is formed by those ionic bonds where the sodium transfers one of its electrons to the chlorine, and this causes them to be a little bit positive, a little bit negative, and bond together. So on their own, sodium and chlorine are actually extremely dangerous chemicals. Pure sodium is an extremely reactive metal that will explosively react to air or water if it comes into contact with those substances. And chlorine is an extremely dangerous gas that is a nonmetal. So on their own, each of these guys very dangerous to people. Put them together and we get something that is put into pretty much all the food that you eat on a daily basis, table salt. So because these guys have that ionic bond and bonded together to make a compound, they end up with properties that are different from their individual pieces. So salt is a very, very common compound in our world. Some other very common compounds are things like water, right? So water is one oxygen and two hydrogen atoms that are bonded together. Again, bonded together, different atoms gives us our compounds. And if we have a substance like, if we have totally pure water, so water is made up of the compound H2O and no other compounds or atoms present, make it one of our pure substances. Another compound you've probably heard a lot about, carbon dioxide, also known as CO2. So again, one carbon atom bonded to two oxygen atoms, different atoms bonded together gives us a compound. So CO2 is what we breathe out of our bodies whenever we exhale. It also is what tends to come out of your car exhaust pipe and out of power plants that burn coal to create energy. And then a compound that I know a lot of people are a big fan of is ethanol. So ethanol is the alcohol that goes into alcoholic beverages. So things like, I don't know, gin, vodka, beer, wine, all of those have low to high amounts of ethanol in them. And so ethanol is 2 carbons, 5 hydrogens, and an oxygen and a hydrogen on the end. And so all of these different atoms are all bonded together. So it all makes one big structure. And that gives us our compound. If you ever had some substance, like usually they're used for cleaning supplies, that is 100% ethanol. So only ethanol is present in there and no other compounds or atoms are in there. That's what would give us our pure substance. Only that single compound is in there. All right, so if we go back to review, just really quick, again, elements, single atoms on their own, grouping together to form a structure. Compounds, different atoms that are bonded together, but they still both fall under the category of being a pure substance if they are the only thing present in that matter. So if we have a 100% totally gold bar, that is a pure substance because it's made out of only gold elements. If we have a glass of 100% water, so only water compounds are present, no other like flavor or air compounds are in there, then that water would be a pure substance because only this one single type of particle, only this one single type of compound is present. All right, any questions so far on pure substances, elements, compounds, anything like that? All right, I know this is one of the kind of trickier things that sometimes take people a little bit longer to figure out in IPC. So if you do have questions as we're going along, this is the time to ask them. So please make sure that you get them out there.
Mr. Stanley, I have a question. Like you said, pure substance, it can be both element and a compound, or just it has to be just one type. I mean, I guess.
So it would have to be either or.
Either
so a pure
or.
substance could be either purely an element or purely one single type of compound. But if you get compounds and elements both mixing together, then you don't have a pure substance anymore.
Okay. All right. Thank you.
So like if some of these black dots from whatever element this is ended up over here in this picture wouldn't be a pure substance anymore. It would be the thing that we're going to talk about up next. All right. Yes, Mr. Matt, you got a question.
You said when it decomposes, can it decompose? What do you mean by that when it's a atom?
Good question. So that was on our little flow chart over here, asking if it could be decomposed by chemical means. What that means is, can we split this substance apart into smaller pieces through like a chemical reaction?
Oh, okay.
So elements are little individual atoms, so they can't be split apart anymore, right? You can't have just neutrons or just protons floating around on their own. That doesn't work for them. They are as pure and as simple as it gets. Compounds, we could potentially decompose them through a chemical reaction. So we could go through some sort of reaction that breaks our ionic or covalent bonds and causes like these two little white guys to be split apart from this black dot right here, this black element, whatever it is.
Okay.
That's what it means when it's asking about chemically decomposing. It's essentially asking, can we take that substance and break it down even into smaller atoms? If we can, it's because we have a compound on our hands. If we can't, that's because it is already just atoms. We can't break it down any further. All right, that makes sense. Okay.
Yes, perfect.
Awesome. All right, so Jessica's question from a little bit ago is actually right on track for what we're talking about next, which is mixtures. So if pure substances are when we only have one type of particle present, either single elements or one type of compound, mixtures are where we have multiple substances all mixed together, hence their name. So two or more different pure substances. So like in this case, right, we have a whole bunch of different substances in this mixture. We've got this black element, we've got these double white elements, and we've got this black and white compound right here. So we have different elements and a compound all combined together into one substance, and that gives us our mixture. Right? So not everything in our mixture looks exactly the same, right? Unlike our pure substance earlier, where everything in a pure substance looks the exact same. So hey, they have these single dots or these compounds, but they're all the same. In a mixture, we can have lots of different stuff, multiple different particles, all mixed, all combined together. That gives us our mixture. So there's two main types of mixtures that we're going to be talking about today. One where all of the different elements and particles are all very evenly distributed, and one where they're not and they tend to clump together. So a homogeneous mixture, which you might be able to guess from the name if you know a little bit of Latin, this is the one where all of our pieces, all of our different particles are all nicely and evenly distributed. It's also sometimes called a solution. So the reason I said that you might be able to figure out is homo is a Latin prefix meaning the same. So like a lot of people talk about heterosexual relationships versus homosexual relationships. And so in a homosexual relationship, the people in it are both the same sex, hence the homo. Same thing for if you take a biology class and you start talking about genes and alleles. A homozygous combination is when you have two of the same genes, and a heterozygous combination is when you have two different genes. So homo means the same and hetero means different. So in a homogeneous mixture, all of the different particles are evenly and equally distributed. They're all spread out the same distance apart, essentially. This tends to only happen when you have very, very small particles. So when they're really small, they're able to more evenly distance themselves apart. And the particles never separate or never settle out from one another. So like if you're mixing up a big jug of like lemonade, like pure, fresh squeezed lemonade, right? You squeeze the lemon and it gets into the juice and you mix it with the sugar and some water, but maybe some of those pieces of the lemon came out. So maybe you have like some pulp and some seeds that kind of drift down to the bottom. That doesn't happen in a homogeneous mixture. In a homogeneous mixture, every single area of the mixture is completely the same all the time. So one example of this would be stuff like medicine. So a saline solution, like these eye drops that you might use for your eyes, every single drop out of that little eyedropper is going to have the same combination of water and saline and medicine in it, right? If it didn't, then this company would have a problem because you wouldn't know what you're getting every time you pushed on that little dropper. So all of the different particles are very small. They're all totally evenly distributed apart from each other. And so because they're totally evenly distributed, you get the same amounts of compounds and elements every time you squeeze out a drop. Every single drop of this solution should be more or less the exact same as the drop that came before it and the drop that's going to come after it. So some other kind of common everyday examples of homogeneous mixtures would be things like mouthwash. So if you look at a bottle of mouthwash, right, it's totally clear. It usually has some sort of coloring in it, but it's not like you can look in and see little particles of the mouthwash moving around each other, right? Every single gurgle of mouthwash, the swig that you take, is going to have the same mixture of chemicals in it. Same thing with stuff like vinegar. So vinegar is a combination of a compound called acetic acid and water. And so in vinegar, every single time you pour out some vinegar from this bottle, it's going to be the same concentration, right? It's not like as you get closer to the bottom of the bottle, the vinegar gets stronger and stronger. All of the vinegar and water is completely evenly mixed together so that each capful that you get has the same concentration of vinegar. Same thing with coffee that's had the grounds filtered out, right? So when the water moves through the coffee grounds, it takes in a bunch of that flavor compounds and caffeine and stuff that was in those coffee grounds. And then all of the little flavor chemicals are small enough to where they can be evenly mixed throughout the coffee, right? So hopefully if you have a good filter on there and you have a good strainer, then each cup of this coffee should be the same as the other one, right? You hopefully aren't getting any coffee that is getting stronger or that's getting weaker as you make your way through a single pot. Now, if you had something like a fancy French press type coffee, like my wife likes to use sometimes, that's different because on that one, all the grounds are squished down at the bottom by a little holder, and then the water and the coffee sit along up top. So that would be a little bit different. This is just a normal drip coffee, and so all of the coffee and caffeine flavor molecules are all evenly mixed throughout here. And then also, smooth peanut butter is a good example. So every scoop from a jar of smooth peanut butter should have the same combination of ground peanuts and oil and sugar all mixed into it, right? It's not like you shouldn't be getting any like super oily scoops or like super sugary scoops of peanut butter. They should, if the manufacturer mixed it correctly and mixed it all up really well, they should be all of the same scoops. So that's what we mean by homogeneous mixture. Everything is the same throughout the entire mixture. There's not any extra compounds in one area of the mixture versus the other. They're all equal and even throughout. On the flip side of this, we've got heterogeneous mixtures. So in these guys, we have uneven distribution of our particles, of our different compounds and components. So like with the example earlier, if homo means the same, hetero means different. So heterosexual couples means that they are different sexes. Heterozygote genes means that you have different copies of the gene. And heterogeneous mixtures means that it is not the same. There is uneven or unequal distribution of all of the different particles and components. So maybe there are some areas where we have some certain chemicals that are super clumped up together. Maybe there's other areas where they're really spread out from each other. It's not all the same. So for example, something like granite. So rocks like granite are made up of tons of different minerals, all kind of compressed down into a single structure, a single rock. And so if granite was a homogeneous mixture of those minerals, then we would expect to see a completely smooth, kind of grayish colored rock. Instead, we have all of these different little speckles of black and white and gray and silver all mixed in here. That's because different areas of the granite are higher and lower or lower with different minerals. And that's what gives it this kind of speckled effect across the granite. So some other kind of everyday examples of heterogeneous mixtures would be something like a salad. So when you're eating a salad at home or at a restaurant, not every single bite is going to be the exact same, right? Some bites maybe have more salad dressing than the other one. And one might maybe you just got spinach, whereas in the next bite, you got a whole bunch of fruit as well as some spinach on there. Maybe some of the bites have some pecans in them, but some have cheese. Each bite is going to be a little bit different from the other one. And that's because our salad is not completely evenly distributed or mixed together, right? We've got these big pieces of blueberries and strawberries and nuts and spinach, all just kind of mixed around each other. Same thing with like soil or dirt. If you go into your garden or outside your house or apartment and take a big scoopful of the dirt from the ground, it's going to have a kind of random mixture of sticks and rocks and soil and maybe like a little animal or two living in there. So dirt is not homogeneous, it is heterogeneous. We've got all sorts of different amounts of rocks and sticks and dirt all clumped together in different ways. That gives us our heterogeneous mixture. Certain salad dressings, like Italian dressing, are very heterogeneous. You can even see in this picture of this bottle, we've got this orange liquid that makes up the dressing, but then we've got all these tiny little red peppers and little garlic bits and other types of peppers and tomatoes and stuff all crushed up and mixed in there. So because we have these little clumps of peppers throughout the zesty Italian dressing, it is a heterogeneous mixture, right? Not every single pour of the dressing is going to be the same. Some might have a little bit more of the red peppers. Some might have a little bit more of the little garlic pieces. It's not completely and totally equal and even. All right, so before we go on to the kind of final review stage, anybody have any questions so far about our mixtures? The homogeneous, the heterogeneous, what a mixture is? Any questions on mixtures? Well, it doesn't look like, hold on. I'm having trouble getting the chat to show up for some reason. Regardless, it doesn't look like anything is coming up in the chat either. So just to kind of review everything that we've been talking about, we have our matter. If it is just one single type of particle present, only one type of element or compound, then it is a pure substance. Only that one particle goes into that substance. On the other hand, if we have lots of different matter, lots of different particles and substances all combined together, that is a mixture. If our mixture is totally even and equally distributed, all the different parts have the same balance of substances in them, it is called a homogeneous mixture. So that's what it means by uniform composition. That's just a fancy way of saying totally equal and balanced. If it is not that, if we've got a whole bunch of clumps of different particles or different atoms over here versus not that many over here, we've got a heterogeneous mixture, right? We've got a salad situation on our hand. Every single piece is going to be a little bit different than the other ones. If it is a pure substance, if we only have that one single type of particle that is present, then it can either be a compound where we have a chemical bond between different atoms that is keeping them together, or we might have a element where there's only one single type of atom present. So it's not even bonded to everything. I will say one thing that I want to mention is that it is still an element if it is an atom bonded to itself, essentially, or two of the same atoms bonded together. So like this guy right here, these two white dots together, that's still an element because they are not different, right? So there's a lot of atoms like oxygen and hydrogen that really like to bond with themselves, right? You'll almost never find a single oxygen or a single hydrogen atom floating around in nature. It'll almost always be O2 for two oxygens or H2 for two hydrogens. And so this is still an element because it is not different atoms together. It's a compound when it's different atoms, but if it's the same atom, it just happens to be two of them instead of one of them. That's what gives us our element, is where we have the same ones together. We could also have separate elements like we've been talking about, but I just wanted to highlight that guy as also being a type of element. Because again, it's the same. There's not a different atom that's stuck in here. It's two of the same ones. All right, so yeah, two or more different atoms bonded together gives us a compound. And if it's only one type of compound in a substance, it's pure substance. If there's only one single atom present, if it's either on its own or bonded to itself, that gives us our elements. And then again, if there's only one single type of element present, that also gives us a pure substance. If there are lots of different elements and compounds all mixed together, that's what gives us our mixtures. And then a homogeneous mixture is when those elements and compounds are completely, equally, and evenly distributed throughout. A heterogeneous mixture is when those elements and compounds are not equal. We have clumping and unequal spreading out of those substances. Alrighty, so there's actually two assignments that are going to be based off of the notes for today. But like I mentioned on Monday, since you guys are also working on your midterm this week, these assignments are both pretty short to make it a little bit easier on you. So today's assignment has the first page is a bit of a review from some of the stuff that we've been talking about today, going back to kind of using the black dot, white dot examples. And then the second page is where the answers actually are, where the homework actually begins. And so for each one of these pictures on this first homework, part 1, there's only 2 pictures. I want you to tell me 2 things for each picture. First, on the first line that's labeled here, I want you to tell me if this picture represents a pure substance, a homogeneous mixture, or a heterogeneous mixture. Then on the second line, I want you to tell me if there are elements, compounds, or both of them present in the picture. So first line, first question is it a pure substance or a homogeneous or heterogeneous mixture? And then the second line is whether or not there are elements, compounds, or both pictured in the image. And then the exact same thing for the second image, the second picture down here. So this is the Google Doc version. If you want to do the Google Form version, I simplified it for you a little bit. So on the Google Form version, we have the same information. I posted in a picture up here in case you want to review it again. And then for each one of these substances, we have those same 2 questions, but now instead of having to write it out, you can just pick an answer. So again, for each substance, determining if it is a pure substance or a homogeneous mixture or a heterogeneous mixture, and then which type of particles are present in here. Is it only elements? Is it only compounds? Or is it both of them? So that's the assignment for today. Again, only 2 questions. And then the assignment for tomorrow is a continuation of it. So it's essentially the same thing, just with a couple more examples. So again, set up the exact same way. Same thing for the Google Form 2, where we have a series of pictures. And for each picture, I want you to tell me if it is a pure substance, a homogeneous mixture, or a heterogeneous mixture. And then, are there elements present? Are there compounds present? Or are both of those types of particle present? All right. So, like I said, only 2 questions for today's assignment and 3 questions for tomorrow's assignment, to make sure you have plenty of time to work on the midterm exam over the course of the next 3 days, today, tomorrow, and Friday. Alrighty. So that's pretty much everything that I wanted to share with you guys for class today. Anybody have any final questions on the compound stuff, the mixture stuff, the homework coming up, or the exam that got posted today? All right, I'll make sure that there's nothing going on in the chat either. Doesn't look like it. All righty, awesome.